So today I will present you some of the results of the Mesoamerican Project looking at HIV transmission dynamic in Mesoamerica. So as you may know, the migration of population is one of the most important factor in the spread of communicable disease, including HIV. And among the main cause of human migration, of spread of infection, there's an increased rate of human interaction, obviously, but also connection between areas of low and high prevalence and increased high-risk sexual behaviors. And as you may know as well, the Mesoamerican region is one of the world's largest congested route of human migration in the world. So among the main driving factors are the poverty, obviously, but also violence, drug and sex trafficking, and war and local conflicts. So based on this observation, the Mesoamerican Project was developed, and as you can see on the map, it includes a lot of centers across 7 countries. All these centers are just here. So you have centers from Panama, Salvador, Belize, Honduras, Nicaragua, and Mexico. And the main objective of this large collaborative project was to first infer transmission network across the region, but also to determine some patterns of viral dispersal in the region. So what we did for this specific sub-analysis, we focused on HIV subtype B collected within the last 5 years. So it represents around 6,000 sequences collected within these 5 years. And as you can see on the map, I just show you the density of sequence collected during these 5 years. So there's some discrepancies, but you have a good representation of the centers that were involved. And here I just first reconstruct a global transmission network of all these sequences, looking just to give you a picture of the transmission in this region. So we use the threshold of 1.5% of genetic distance for HIV pulse sequences, and we found an overall rate of 23% of clustering in this population, with some interesting findings, such as these 2 large clusters in Guatemala here. And we found also that people living in Mexico and in Guatemala were more likely to cluster. And we also found that younger MSM were also significantly more likely to cluster than heterosexual or female. And we also look at sites that where people living, such as in Mexico or in Guatemala area, for those who don't know where is Guatemala, were significantly more likely to cluster. Looking at transnational clusters, so meaning that clusters including people from multiple countries, we found an overall rate of 5% of transnational cluster, with predominant linkage between Mexican and Honduran sequences. And among these transnational clusters, we found 6 larger clusters with more than 10 individuals. So based on all these descriptive information about the epidemic and the molecular dynamic of transmission in the region, we try next to look at the diffusion, the viral dispersal of HIV in the region within the last 5 years. And so to do so, we try to apply different approach. And the first one was to introduce a Bayesian probabilistic framework with prior specifications that include for each sequences not only the date, but also geospatial information. And based on this information, we made a Bayesian inference to look at the viral dispersal over time. And here I just made for you a very limited, on a very limited dataset, I made you an animation to show you the dispersal over time from 2011 to 2016. And you can see clearly the spread of HIV from specific region, like here from Guatemala City or from Mexico City. So these tools are interesting and give you an idea of the spread of HIV within a region, but they are limited by some computational resource. So to deal with very large amount of data, you need an alternative approach. So what we did next to account for these 6,000 sequences, we introduced a more formal probabilistic method. It's a tree-based method as well, but it's more statistical approach. It's called the Slatkin Manistal approach, And what it does, it looks within a tree at each transition from one state to another. And each transition corresponds, if you like, as a migration event from one location to another. So, and because of the large discrepancy in our dataset in terms of sampling density, what we did is we first divided Mexico into 3 areas, the north, the center, and the southern region. And then we randomly subset 40 sequences from each country and each location to have the equal number of sequences everywhere. And then we performed 100 iterations of this Slatkin-Maddison statistical approach to get a better idea of migration pattern in the entire region. So, and the results are summarized here in this heat map. And what we found is that the center of Mexico and the southern region of Mexico were significantly more likely to be the source of viral migration, mostly directed towards the northern region and the southern region of Mexico. And we also found, as I just said, some interesting pattern of migration within Mexico, driving from the centers toward the southern and the northern region. So based on all these results and the key role of Mexico in driving the local epidemic and the regional epidemic, we next look at the HIV epidemic within Mexico to get a better idea of what happened within each state. And this is just a summary of what I just said in a different way. So clearly see the role of the center and the south of Mexico as major source of viral migration. And so next we focus within Mexico. And to do that, we look back at the sequence collected over the last 15 years. So, and as you can see, there were clearly 2 different programs with different centers that were involved before 2011 and after 2011. So what we did, we simply divided this analysis into 2 sub-analyses. And we first performed the same approach to infer the transmission network before 2011 and after 2011. And we found similar rate of clustering around 26 to 30%. And clustering individuals were predominantly men. And we found an overall rate of 30% of multi-state clustering, meaning clusters that include individuals from multiple states. And this is before 2011 and after 2011. But maybe more interestingly, we found that people living in some particular states, such as people living in Chiapas before 2011 were more likely to clusters, or people living in Baja, California, or in Quintana were also significantly more likely to cluster. So we focused on this particular region, and we found that in Chiapas, for example, we found only heterosexual clusters. That is totally different from what we showed previously. And this is interesting because, as you see here on the map, Chiapas is close to the border region of Guatemala, and it's known to be one of the most vulnerable states to human trafficking, so it could be a local driving factors of the epidemic locally. Next, after 2011, we've also found that people living in, living in Quintana were significantly more likely to clusters. And as you may know, Quintana is well known for Cancun, so it's maybe one of the driving factors of the epidemic locally can be tourism, and maybe sexual tourism, and increased high-risk behaviors. So altogether, from these preliminary results, we found a limited transnational clustering in the region with around 5%, similar to what we found before. But we were able to identify with different approach the key role of Mexico as a source of viral dispersal in the region. And based on this, we did a sub-analysis within Mexico and found some interesting findings about border states such as Chiapas and Quintana Roo. So I'd like to thank you, everybody, and all the collaborators. So, yeah.
Thank you for that very illuminating presentation. Are there any questions? Yes.
Really amazing amount of work. Very impressive. I had 2 questions. Since the samples were collected over a period of time, do you have any idea whether you sampled the same people more than once?
Yeah, it's unique individual. Unique individual.
So they were identified in some way?
Yes. Yeah. Yes.
And And of the people who you sampled in different places, do you know where they resided originally?
We
So
don't
the
have-
ones in Mexico could have been from Guatemala?
Totally. We don't have this information for most of them. We don't have. Yeah. But
That was a really interesting presentation. Thank you. This morning, Dr. Strathy in her keynote presentation showed some other data from the world that made it look like rather than the disease being spread from places like Africa to the U.S., she talked about how the spread was coming from these more developing areas out to other parts of the world, and it almost looks like you found the same thing.
I did the analysis.
Pardon?
I did the analysis for the other study that was presented this morning with Sanjay, looking at migration from Tijuana to San Diego and reversely. And yes, so I tried to apply the same approach to this very large data set. I am in the process to tweaking the code to be able to generate the same kind of results with most common ancestor and the migration over time with some nice plot, but I'm still working on it. So.
Okay, thank you. And so my question is, it looks like you found something similar with, it looked like, you know, that the disease was concentrated in places like Mexico City and then spreading out from there to other parts of Central America. What would be the response to that? I mean, it sounds like it could be that people are going to these places, as you mentioned, sexual tourism to places like Cancun, but it almost sounds like the highest concentration of mixing and spread of the disease occurs in these densely populated areas and then gets disseminated when people go home.
Yeah.
Any thoughts about what the intervention would be to try to minimize that problem?
I think we need to focus on high-risk population within densely populated area like Mexico City or Cancun, because there's an increased rate of human interaction in this densely populated area. And this is interesting because I found the same findings in France, in Paris, spreading from Paris and from specific centers in Paris or from Marseille. And we are studying Germany database actually, and we found the same thing from Köln. So this is clearly something we found in many places. Yeah.
So we need to really focus our intervention
to limit interaction, in a way.
Just to add on what, I'm sorry, what was your name? What Richard was saying, and I was just wondering if you could touch upon human trafficking and if that is a questionable proponent of what you're seeing and what your results are.
Sorry, I didn't.
Oh, just to touch upon what Richard was stating, I was wondering if you could comment on human trafficking and its possible role in your results.
I don't, yeah. Kind of.
About talking about human trafficking and its potential role in your results.
Oh yeah, definitely, yeah, sorry, I didn't hear you. So I think in Chiapas, we have something, yeah, very interesting, but unfortunately Chiapas is just a former data set from before 2011, and we don't have ongoing data sets in Chiapas, so it would be very interesting to have more granular information about this specific heterosexual cluster, because this is very uncommon. As you see, 80% of the people clustering in my global dataset were men, and in Chiapas, there were only heterosexual clusters, which is quite unusual. So I think we definitely need to focus on these border states with some specific question, but we have something here, but unfortunately I was not able to do any follow-up analysis because we don't have any sequence from Chiapas since 2011. But I think if we can publish some results, they might be interested in.